Hello and welcome to my video, lesson 7.1, Intro to Logarithms. So in this video we are looking at logs, and we're looking at what they basically are. So what is a log? So we normally write like log base of something, and normally we're looking at base 10, and then we have a number in here, so 100, and then we're trying to solve it, okay? So a log is something like this. So we'd have 1, 2 would be the answer here. We'll look at that answer and what that means in a second. But basically, a log is like this, is like an exponential function. So let me just change that to maths so it looks more clear to you guys. So anyways, a log is like an exponential function where the base is the little 10 in here. That's the base, okay, as shown. And the answer is in here, so that's the answer to the exponential function. And the exponent for the exponential function actually becomes the answer for the log. So for example, 10 to the 5 would give you, you count the zeros, so this is 100,000. And so if you did log 10 to 100,000, it would equal 5. So it's basically just a rearranged version of an exponential function. So generally, if we write log and it doesn't show a base, doesn't have a base in the thing, that means it's base 10. So it's just convention to go with base 10, probably because we have 10 fingers, 5 fingers on each hand, but that's probably some sort of polydactylism, 10-fingerism. I don't know what the term for that would be. But anyways, so anyways, it's base 10. So if it doesn't say it, that means that it's base 10. And so if you did this one, you could kind of think about it as rearranging to solve this. Like maybe we'd pretend we don't have that 3 there. So we'd go 10 to the what equals 1,000. Right? So that would be the question that we'd be asking ourselves. And so the question would be then, okay, what is x? Well, we'd say x is, and then we can count the zeros, and x would be 3. And so that's what we get. So that's basically the process to solve these in a basic question. What else do we have for logs? Well, we have natural logs. So we can have base 10, which is probably the most common to have in this course. And then we can have base e. Well, what is e? E is a special number. It's a ratio, a special ratio. Kind of like pi, it goes on forever, as in there are numbers that keep going, and it never repeats and goes on forever, and you can calculate it like pi and all that sort of stuff. But it's a pretty special number, 2.718 blah, 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 okay? But we don't have to worry about it too much. Just know that it exists, so base e. And so if you have log base e, we'd actually write it like this, ln, which is the natural logarithm. Or in French, they switch the letters, the words around, and so it's like logarithm naturel or whatever, so that's why it's ln instead of nl. And then 2, so anyways, you could put that in your calculator and try to solve that. Sorry about that ringing. It's the school bell or whatever. The after hours, if someone's trying to get in, that bell goes off. So the graph looks like an exponential graph, but notice the x and the y have switched places. So normally, an exponential graph looks like this, and perhaps I can even pull up my graphing calculator and show you guys. But normally an exponential function would look something like this, where we have a graph looking something like this. Let's try to also draw the logarithmic graph. How would that look like? Okay, and it would look something like, I want to actually graph it, so just give me a second. The graphing calculator takes a little bit to boot up, so. No, come on, you need something else to What? There you go. Okay, so our first graph is 10 to the x, and our second graph is log of x. So it's kind of like if we flipped it around and switched the x and the y. And so what that means is that our 10 to the x graph looks something like this, while our log x graph is kind of backwards from that, right? So our 10 to the x, it never quite reaches 0 when it's going into the negatives. And same thing with this one, except the negatives are in the y direction. It also continues forever positive in the x direction, just like the other one continues forever positive in the y direction. So you can kind of imagine that it's a flipped and rotated version of the exponential function. You could also think, could look at it perhaps that it's flipped around that, or reflected around a diagonal. That's another way you could potentially look at it. But anyways, those are logs. And so this is just the basic introduction, and watch the next video if you want to know more about logarithms and eventually how to solve them. Good luck.